2 to 3. So how would we figure this out? Well, let's set this up. I know that the ratio of B to A is equal to 3 to 2, or 2 to 3. Okay, so it's going to be 2 to 3 is my ratio. But it doesn't mean that A and B is 2. But we could say this. We know that if I use an n here, I know that 2n must be equal to b, and n could be, 1, so b would then be 2, and then a would be 3. N could be 2, so be 4 and 6. We could have any proportion of n, and it still keeps the same ratio, but then allows us to solve for the actual value of b and a. So this is what we're going to do then. We're going to just replace the a and b with these expressions. Okay, we're going to replace them with this 2n variable and this 3n variable, and then we're able to express this in terms of one variable, which then it will make it much easier to solve. So it's going to look like this. I'm going to say that x squared over 3n squared minus y squared over 2n squared. Okay, and that's going to be equal to the positive 1. So now I have that instead of two variables a and b, I just have it in terms of one variable n. If I can plug in for x and y, which I can, I have a coordinate on the graph, the 7.5 and 3, I can now develop an equation to solve for n. Okay, and this is very important that you understand that I can solve for these coefficients if I can plug in the point. Okay, and I have enough variables or enough equations or relationships to be able to solve that system. In this case, we've reduced that system from two variables to one variable n, and then now we can plug in our x and y values to actually solve for that. So x equals 7.5 squared over 9n squared minus y is going to be 3 squared over 4n squared, and that's equal to 1. Okay, this is going to, actually I'm going to leave it maybe like this. I'm going to leave this as 3n squared, and I'm going to leave that as 2n squared. And this allows me to just simplify this ratio, because I know that squared can be put on the outside, and I can simplify that 7.5 over 3 into 2.5 squared over n squared. And I'm going to simplify, since the squared is on the outside here, I can simplify the ratio inside. And I can make that 3 over 2 into 1.5 squared over n squared equals 1. And that makes it a little bit easier to solve for n. So 2.5 squared minus 1.5 squared. And I'm just going to multiply the n squared to this side, which then allows me to solve for n. So n equals plus minus 2. Okay, we don't need the plus minus in here, so n is equal to 2. Okay, that then allows me to solve for the a and b values. Okay, so b is equal to 2 times n, which is 4, and then a is equal to 3 times n, which is 6. So now I've actually solved for my a and b values. I've actually solved this equation. Now I can just put it into its graphing form here. So I end up with x squared over, that's going to be 36, minus y squared over 16, and that's equal to positive 1 since it's a trans x-axis. Okay, so there's the equation of my hyperbola. I know that it's trans x, so I know that my vertice now is at 6. Okay, so that's going to be at 6, 0, and I have another vertice here at negative 6, 0, being trans x, and I can draw my hyperbola through that coordinate, like that. Okay, so then just follows the asymptotes here, follows the asymptotes here, and again, I just need the vertex and the asymptotes, and that should be able to give me the correct shape of that hyperbola.